If you were participating in a trivia pursuit game and your question was which material is most used in building infrastructure, what would your answer be? Well, the answer would be concrete. Concrete is the most widely used construction material in the entire world. It serves as the backbone of industrialization, playing a very crucial role in our building infrastructure. Now, here are a few key points about concrete. Immensity. There is twice as much concrete used in construction than all other building materials combined. And applications. Concrete is used in various infrastructure components, including bridges, piers, pipelines, buildings, roads and overpasses, railways, water supply systems, wastewater treatment and sewer systems, electrical grids, and telecommunication networks that also includes internet connectivity and broadband access. So its durability, its versatility, and its widespread availability, it makes concrete an essential material for shaping our world's infrastructure. So typically, how is concrete used? Well, steel is typically used in concrete in several different ways by enhancing its properties and performance. Let me cover some key applications. The first is reinforcing steel, and that would be rebar. And the purpose of rebar is to provide tensile strength to concrete, which is otherwise weak to tension. Now, how does it work? Rebar is embedded within the concrete, and it forms a composite material known as reinforced concrete. The concrete provides compressive strength, while the rebar handles tensile stresses, which are caused by forces like wind, earthquakes, and vibrations. Steel fibers. The purpose of steel fibers would improve the toughness, the ductility, and also crack resistance of concrete. And how it works, steel fibers are added into concrete mix, and as a result, steel fibers enhance flexural strength, reducing shrinkage cracks, and improve the resistance of impact. Applications include industrial floors, pavements, and tunnel linings as well. Metal decking. Now, the purpose of metal decking serves as a framework or a formwork, during concrete placement. And how it works is corrugated sheet metal, such as steel, is supported by steel joists or beams, and concrete is poured on top of the metal deck, creating a composite floor deck system. And it's commonly used in commercial buildings, bridges, and also parking structures as well. Metal dowels and tie bars. And the purpose of metal dowels and tie bars are to connect adjacent concrete sections such as slabs or walls. And how it works, they transfer loads and prevent differential movement between concrete elements. And dowels are used in expansion joints, while tie bars reinforce joints and concrete pavements. Metal reinforcement in precast concrete elements. The purpose of precast concrete elements, such as beams, columns, and panels, are often contain embedded metal reinforcement. And how it works is that the metal reinforcement ensures structural integrity and load-bearing capacity in precast components. It's essential for transportation, lifting, and assembly. To sum things up, steel plays a crucial role in enhancing the strength and durability and performance of concrete structures. Now let's have a general conversation about corrosion mechanisms within concrete. Corrosion in concrete structures is a significant issue that affects their durability and performance. Let's explore the mechanisms behind concrete corrosion. The first is corrosion of reinforcing steel, the rebar. And the cause is the interaction between steel reinforcement, the rebar, and the surrounding concrete environment that leads to corrosion. Now, how the process happens is when steel corrodes, it forms rust, iron oxide, which occupies more volume than the original steel. This expansion creates tensile stresses within the concrete, eventually causing cracking, delamination, and spalling. Electrochemical process This is a corrosion that involves the flow of charges, electrons, and ions. Active sites on the rebar anodes lose electrons, while cathodes combine electrons with water and oxygen in the concrete. The resulting rust weakens the steel. Number 2, factors influencing corrosion. Chloride ingress. Chloride ions from de-icing salts, seawater, or marine environments penetrate concrete and accelerate corrosion. Carbonation. Carbon dioxide reacts with calcium hydroxide in concrete, reducing its alkalinity, and this makes steel more susceptible to corrosion. Moisture. High moisture content in concrete provides the necessary electrolyte for the electrochemical process. And oxygen availability. Oxygen is essential for rust formation on steel surfaces. Now, structural impact. Reduce load-bearing capacity. Corroded rebar loses strength and compromises the load-bearing capacity of concrete structures. Cracking and spalling. This comes from tensile stresses from rust expansion that causes cracks and surface spalling, exposing the rebar to further corrosion. And reduce durability. Corrosion weakens the overall structure, affecting its service life and safety. Now, for preventative measures, you have coatings and sealants. You want to apply protective coatings or sealants to prevent moisture and chloride penetration. Cathodic protection. The use of impressed current or sacrificial anodes protect rebar from corrosion. High alkaline concrete. Design concrete mixes with high alkalinity. And this would be a pH of a greater of 12.5 or greater to maintain passivation of steel. And then proper cover thickness. Ensure adequate concrete cover over rebar to protect it from external elements. Understanding these mechanisms and implementing preventative strategies are crucial for maintaining the integrity and longevity of concrete structures. Now, how can concrete structures be protected against corrosion challenges? First, let's cover cathodic protection, which is a method used to control the corrosion of steel in new concrete, even contaminated concrete structures. Here's how it works. The corrosion mechanism in concrete. In reinforced concrete, a passive oxide film forms around the reinforcement steel due to the alkalinity of Portland cement. This film protects the steel from corrosion. However, aggressive ions such as chlorides attack the concrete around the reinforcing steel. It weakens or destroys the oxide film, and this leads to corrosion of the steel. Now, corrosion, as I mentioned earlier, is an electrochemical process with an anodic and cathodic areas formed on the steel. When the circuit of the corrosion cell is completed by continuous steel bars connecting anodic and cathodic areas, and by immersion in the same electrolyte, corrosion occurs at the anodic regions. Cathodic protection process. Cathodic protection makes the embedded reinforcing steel cathodic, which would be negative. And this accumulation of hydroxyl ions around the steel makes it passive for a long time. Now, two methods of cathodic protection. You have sacrificial passive systems, which use less noble metal like zincs as an anode. It corrodes sacrificiously, protecting the steel. An impressed current cathodic protection. An external power supply forces a small electric current through the reinforcement steel, counteracting the corrosion process. A metal like platinum serves as the anode, corroding very slowly. Applications. Cathodic protection is used to protect almost any type of reinforced concrete structure, including horizontal slabs, walls, towers, beams, columns, and foundations. However, it does not replace corroded steel and has limitations for pre-stressed concrete structure and post-tension structures. In easy terms, cathodic protection helps maintain the integrity of concrete structures by making the steel cathodic and preventing corrosion. Now let's pivot to protective coatings used on concrete structures. Protective coatings play a crucial role in safeguarding concrete structures from corrosion. Here's how they protect concrete. The first is a barrier effect. The function of a protective coating is to act as a barrier between the concrete surface and the surrounding environment. In the mechanisms, coatings prevent water, oxygen, and electrolytes, such as chlorides, from directly penetrating and contacting the underlying steel. And when this is going to be your reinforcing steel or what would be your rebar. And the result, by blocking these necessary elements, coatings inhibit the initiation of the coating or the corrosion process. Inhibited properties. Now, some coatings contain chemicals that actively hinder corrosion, and these inhibitors interact with the corrosion or corrosive agents, slowing down the electrochemical reaction that lead to rust formation. And inhibited coatings are particularly useful in aggressive environments where concrete is exposed to chlorides or other corrosive substance. Physical protection. Coatings physically shield the concrete surface from mechanical damage, abrasion, and chemical exposure. And coatings can be polymer-based, like epoxies, polyurethanes, metallic or zinc or aluminums, or hybrid systems. Now, by providing an additional layer, they enhance the durability and longevity of concrete structures. In color and aesthetics, coatings not only protect, but they also enhance the appearance of concrete surfaces. Architects and designers select coatings based on both the protective properties and aesthetic preferences. Now, coatings can impact colors. They can impart colors, textures, and decorative finishes to concrete. To also make what I covered easier, protective coatings act as a shield, preventing corrosive agents from reaching into the concrete and reinforcing steel. Coating applications is an essential point of protection for maintaining the integrity and longevity of concrete structures. Now, that's all I have time to cover. Thank you for tuning in for this week's episode. I hope you found this episode insightful and you gained some valuable knowledge. As I'm heading out, let me mention to you that this past month, Coatings Talk now has a LinkedIn group, and we're now building a strong community for the coatings and corrosion professionals and others who support both industries. The community purpose is to share members' experiences, their expertise, information sharing, knowledge transfer, showing a passion, and also highlighting skills and more. So please join the Coatings Talk community, and I'm looking forward to working with new members like you. Join me next time as I continue our Coatings Talk to dive deeper into topics such as coatings technology, surface preparation, coating application, quality inspection, and more. And don't forget to subscribe to the Coatings Talk channel to stay updated on the latest episodes. I greatly appreciate your support and look forward to bringing you more exciting content on the amazing global protective coatings and corrosion industries. Okay, thank you, and please have a great evening, afternoon, morning, no matter where in the world you're watching this broadcast.